Good morning, everyone. I'm Ashenafi from World University. Today, I'm going to present you our joint work research entitled as Generative Adversarial Network-Based Visual Aware Interactive Fashion Design Framework. And the main intuition behind of this research will be presented in this presentation. So I will quickly start from the introduction. The domains of fashion requires a large as a huge investment, and due to this huge investment, so the requirement of this huge investment, we need to have actually an effective design principle in order to create a fashionable, wearable, and non-wearable materials. It can be fashion and other related works. So the world even invested $521 billion in 2019, and the research 2020 due to the COVID outbreak, it declines by 8.5%, which is $485 billion. It expected in 2023 it will increase to 11.4%. In our country, Ethiopia, even there is no well-organized report. 150 million dollars were invested in 2015 and 120 million in 2020 and 19 budget years. And it's expected in worldwide or at the world $953 billion in 2024, which is a huge investment in the world when we compare with other sectors. So whatever the case, this fashion fashion design requires an effective design principles, and so the introduction of artificial intelligence plays a significant role whenever we design a user preference selling and what we call buying principles or mechanisms. So AI plays this role. Uh, Apart from AI, which is generative adversarial network, can plays a significant role in order to generate or design new designs as per the user preference, or we can record it as user preference design. When it comes to the motivation, actually GAN originally when Ian Goodfellow, what he called works on this area, GAN, he aims to generate a new realistic item from Gaussian distribution. Originally, whenever you give an image and you will have an output image for that corresponding Gaussian image and the corresponding image which is originally given as another dataset. But the main intuition behind this work is generating multi-conditional fashion images based on a conditional terms through color, shape, and texture. As you can see right here, we do have in different color, different shape, and different texture even. Actually, when I say texture is not physical, what we call matter, rather than which is the stripes and other the color arrangements as well, actually. So, and this research developing the new architecture and integrating with different generative adversarial methods or models is the main intuition, and other just evaluating the model and the performance of the model and the what manner and different mechanisms. But when it comes to the domains of this actually fashion as well as generative adversarial network, there are still strict issues that we need to deal with for further research. So the first one is by default fashion is hard for subjectivity actually means that one user may interest on one and the other may interest on the others. So and the other issue is just there are visual artifacts and a color mapping problem on the current generative adversarial network. And the other is just inconsistency or low resolution whenever we generate an image through different, whenever we use different GAN-based methods for generating fashion image actually. And the third one is just to work with domestic, what we call fashion items, which is Ethiopian or Ethiopic related fashion items or Habeshan items. There are related works or literature reviews that has quite related with this research and purely done by someone. So the first one is fashion recommendation and design, and the author uses what is convolutional neural network for just suggesting items both for prediction, whereas they use GAN method for generating fashion images. even though they did somewhat a good research, but there are strict problems on this research. Yeah, actually they try to generate images with a match, as you can see right here, for a corresponding what you call uh, sweater is there is a corresponding trousers, and even it's possible to prefer some shoes. But the problem is the generated output is the quality of the generated output is just too poor actually. And the other is it's not possible to control fine-grained styles or what he calls different conditions in general. So the extension of this work actually is just fashion GAN a bit. They try to use conditional GAN, so the matter they try to start from some contours, some normal images, some stripes, and even government images. But the difficult over here is this research, even though they use conditional GAN, they try to what he call condition the generative adversarial network nature from what he call just fashion sketches, garment images, and even contour images. Moreover, but they generate some image for some they do achieve success, some successive results. But the problem over this fashion gun, which is they rename it as fashion gun, it works for a singular curves whenever we do have different stripes and different regular curves and matches. It will display blurry arts, what you call artifacts, as you can see right here, you guys. So it fails in different results, and even they present their failed work with their uh, corresponding results section. Uh, moreover, uh, Ildren et al. In 2019, they tried to use a new method, both unconditional and conditional GAN methods. For the sake of unconditional, they just generate through that model, but in unconditional manner, they transfer from one image to the other image through styles, colors, and other matters. But the quality is not as such good, and the model even is inconsistent. And the other is Zhu et al. In 2017. Just they work on just semantic segmentation map through different sentences. Actually, this is also conditional GAN. They use conditional GAN, but the problem right here is just they use a sentence for a condition. Condition actually the semantic nature of the fashion domain as well as just the sector is quite difficult in general. Assume that we are working just conditioning through text. Uh, in order to generate fashion images, so that will not actually generate or what you call will not to have a good output actually. And the other what you call downside or what you call limitation of this work is they use just processing background when actually the actual generated output requires some uh, filtration or pre-processing mechanism in order to remove some low resolution artifacts. So for that matter, it's better to use high resolution or super resolution, what you call generation mechanism. And additionally, the first author also add an additional research which is distinguishing with multi-conditional inputs. But even though they use progressive GAN, which is the best method right now, even style GAN use it. So they use just for generating high resolution fashion images through color and shape. But the architecture is quite actually it's not well described. Even actually it doesn't mean it doesn't seems realistic. Realistic actually it seems theoretical. And the main intention behind actually the new work, which is just to work with, and the last work just to have a clear architecture, and in order to condition with various color, shape, and texture. Moreover, in order to do so, 12,000 images were collected originally, actually, but I try to augment these 12,000 with 10 classes, 100, I mean 1,200 image for a single uh, class, and I try to augment it, and within this ratio the total image after augmentation is 19,000 images, and originally the data is collected for scraping websites, say in Amazon. Actually, I get a permission from them, and advertise websites such as social medias and Telegram channels, and manual connection even by go through what you call Shromeda actually close centers. And for researcher, I use GPU and other software utilities, so obviously. And in order to process, I use normalization, adjusting for some image attributes. And the second is actually color labeling and texture dimension manipulation. And the third is segmentation. Having just deal with these three issues, so the pre-processed image and what you call the label image, simultaneously the segmented mask image is just to create TensorFlow records. Actually, I put this one in TF record. Actually, a binary record which can sequentially represent these three inputs. So original pre-processed image is extracted actually through Excel and actually through segmentation mask image. Actually, I will come right back. So the segmentation mask originally we will give original image, and this image through set some threshold value, it will binarize that one. And having deal with that, we will just also manipulate or compute the average color. Actually, it's possible to compute the domain color and the average color of the image which is originally given as an input right here, and it will write through Pickle or Excel as per we want. So this is a binary segmentation and average color labeling, or what you call manipulation. Having deal with one, just we will go through to what you call a proposed solution. Here in the proposed solution, I have said earlier, we were collect 19,000 images, 19 actually 19,000 images, original images, and we try to augment it. Uh, this one actually we will get 19,000 after augmentation, and we will do what actually segmentation. So the segmented and actually the color actually the original image and the extracted color label will jointly create a TensorFlow records just fit for training. And this training helps to us in order to condition through color, shape, and embedded texture. Actually, the better arrangement is right here. Originally, when GAN proposed by Ian Goodfellow and his colleagues, they try to just what he call generate from Gaussian image. So they used or what he call original image right here with a different scale, and this feed for actually for discriminator, and they feed for the generator Gaussian noise, and the generator will what he call generate a similar images and do the difference through what he call gradient descent, or what he call the difference here. Through dealing this one, it will what you call the discriminator will identify which is real or which is fake. And the generator keeps what you call generate the fashion item until what you call the post, what you call the best, what you call fashion item is going to be generated until what you call the ability of the generator to generate best images like a ways the generator failed to difference the original image and the generated image. So it keeps going until the generator failed to what you call identify which is the original image and the generated image. So originally here in the Gaussian noise, you will have a Gaussian noise, but keep understand right here, it will do what you call progressively. We will have original image. Originally we do have 256 by 256 or 512 by 512. It will downscale until 4 by 4. So progressive GAN, what you call bring the mercy of the principle, just generate from higher resolution to the lower resolution. So the more what you call progressive result will achieve better results. So this will better in order to just synthesize the better image than with the other progressive GAN. So when you come to right here, here an image we will have a Gaussian image, but in this proposed what you call method, or in this proposed research, we do have three inputs. So texture dimension, the segmented mask, and the computed average color. So this will fit for TF record or TensorFlow record, which is binary sequential records in order to fit for the generator. So the generator accepts three inputs as I have said earlier, and it will do its own gradient calculation, or what you call in order to do the loss or the difference right here from the original that we have, and the image, which is the total original image downscale until 4 by 4 from original image 4 by 4. So it will compute the difference. So actually we will have the discriminator loss, also generator losses. So in the generator, we will have actually texture, which is local structure patterns in a certain dimension. You will have color, which is three-dimensional or RGB color. And you will have shape, segmented mask. So this is what what the generator accepts right here, as I have said earlier. So what you will and do, and Goodfellow works on Gaussian noise. Just we work on these actually three conditions: texture, actually the segmented mask, average color, simultaneously with the Gaussian noise. So when it comes to the discriminator, try to actually differentiate or identify which is the real and which is the fake. Actually, not only that, it also computes the average color originally sent from the input article or the input fashion item, and it will calculate actually the loss of the discriminator is actual, the real minus the discriminator distance of the generated image. So this one. Moreover, it will identify the real and the fake. Uh, and the next one is the generated results. Here is actually when we pre-process the augmented result through different augmentation techniques, share actually binarize and actually through different angle of point. And also we did a segmentation mask through different threshold value, as I have said earlier. And the next one is just experimental results with the two mechanisms. So the first one is the generated input, actually generated output image in 4K grid and learned model over the network, and each checkpoint or learned network will serve through checkpoint or pick. So this one is the original one, so the left one is original one, whereas this is generated through actually within the same shape with different, yeah, the same, yeah, generated originally generated without a certain condition, generated within a certain texture with some color condition, and this is also generated through different color, shape, and other matters. So this is a proposed model results or the proposed method results. Actually, there is a progressive GAN, and what we add is just a different conditions on progressive GAN, and that will what we call brings a better result. Actually, it's not the better result. So there are different constraints which may affect the result. So the training, whenever we train with less computing GPU, and even we didn't finish the training actually this one. So here the result we achieve actually right here is just through conditional progressive GAN. So this is conditional style GAN. Actually we add two conditions for conditional style GAN and for conditional progressive GAN. Uh, some stability and improvement has been made on style GAN. Actually the other mechanism or the training procedure over the conditional progressive GAN is quite similar, and the only difference is some stability and uh, what you call super resolution generation has been added in conditional style GAN. I mean style GAN, and we add some additional condition over this style GAN right here. Here, this is a model evaluation. Actually, we did three model evaluation techniques. So the first one is perceptual path length and free chase inception distance. Here, this is what you call the free chase inception distance for 50,000 different images as per the time taken in order to what you call evaluate the model is just this one. Here, the perceptual path length. So this is to mean that PPL or perceptual path length uh, with time estimation results. Here we do have perceptual path lengths with this one and with a corresponding value. Okay. So meaning the significant meaning is the lower 50 what you call free chase inception distance is a better real, or the generated image is actually close with the original image. So meaning the conditional progressing has achieved a better result when we compare with free chase inception distance for 15,000 images. So the same result for PPL for 19,000 images totally we did with through this time frame. So the model evaluation through this time. Here we achieved 1,500 and the respective value for style gun and conditional style gun. So whatever the results is achieved, we achieve the same results in conditional style GAN and progressive GAN actually, but the result is actually uh, achieved through less time in conditional style GAN because some stability has been done on style GAN. So the lower perceptual path length means the better two image close each other. So both the conditional style, progressive GAN and what you call conditional style GAN achieve better results in our based on our evaluation actually. And the third evaluation is human evaluation. Actually, fashion is just subjective. Actually, mathematical calculation and manipulation could not resolve or could not be taken as a better mechanism for in order to as evaluation metrics for results we achieve. Moreover, we had both paired and unpaired evaluation. So this is paired evaluation means paired evaluation. We give both the generated and what he call the original image, and we try to what he call give the users or what he call interested users in order to differentiate which is a generated or which is fake images. And we try to confuse. We get a confusion of this one 42%, 46.2% uh, confusion rate for paired evaluation. But when we come to a single evaluation or what you call unpaired evaluation, we give just one single image. Is it generated or what you call original? Then the user confused 47.6 47.6%. The reason behind the confusion rate of paired evaluation and unpaired evaluation difference is in both what you call impaired and unpaired guess or what you call evaluation, it's just get a bit confused, a bit confused. But when it comes to an unpaired, actually, it achieves some result. Actually, it achieves such results. And the other is just through shape consistency, color consistency, and other. So the overall, when you compare with others, the conditional progressive GAN achieve this one, whereas conditional style GAN achieve this one. Both conditional style GAN actually so this number, so the higher number showed that so the better result we achieved when we compare with texture, shape, consistency, and others with 5 grade from 5 level. This also human evaluation assessment based on such criteria. So we achieved this one when we 39 users actually 62.2% for conditional progressive GAN, whereas 56.5% for this one when you compare with it, and 60.4% for this one. So at the last, what we want to say is building such multi-conditional fashion image generation mechanism will bring a significant achievement, or since it will satisfy the users whenever we do have different color, texture, and shape interests. And the other is the confusion rate for the paired and unpaired user is 47 and 46%. So the model evaluation technique can be free chat inception distance and perceptual path length, and the result is as you can shown right here over the screen. So the experimental result shows us so the fashion design can be done moreover through deep learning model or algorithm easily just before prior to the actual manufacturing industry feed for manufacturer design. So AI can play a significant role in order to generate a better user preference design. So in future, including the relative fashion attributes such as complete texture, printing shapes, and size takes over the different clothes or what you call fashion items as an issue we will actually go through in the future. And the other is just multi-conditionality through different high-resolution working losses. So since it needs internal structure arrangement for different models, and moreover, we wanted to work on 3D data sets and in order to 3D what you call image generation in the future. Thank you. If you have any question, you are welcome. Thank you guys for your patience. Thank you indeed. Any more question?